Namaste. Hope you're doing well. Today we will solve the 8th question of ISI MSTAT 2024 PSA. Fairly straightforward. It's a matrix rank computation question. You are given a 4x4 square matrix and its elements are to be determined by this condition, and then you have to find its rank. So let's get started. Now, connecting some dots. Can you visualize what the matrix looks like? And it's personally my opinion that when the matrix order, the square matrix is of the order 4 or even 5 or less than that, it's easy to visualize it. And we see that the ijth element is neatly given. Basically, whatever row it's in and whatever column it's in, those are being used as indices to have the relevant stuff added. And this is what it's going to look like. So first row, first column, so A1 plus A1. Third row, fourth column, so A3 plus A4. And this is going to be A3 actually. So we see this common element, these common elements, this A1, A2, A3, A4 popping up in every row. So the intuition that can be worked upon next is we can remove these common stuff from the rows or columns, whichever way we want to proceed. And in matrix rank computation questions, we usually do row or column operations because they are legal to do in these cases and simplify the matrix as much as we can. Now, in order to remove this A1, A2, A3, A4 thing in rows, what we can do is, because it's present in every row, we can just subtract the first row. We can remove basically the first row from each of these second, third, and fourth rows. So row 2 minus row 1, row 3 minus row 1, and row 4 minus row 1. And we get something like this. And it's clean because then the entire second row is basically kind of a constant multiplied by 1, 1, 1. And similarly for row 3 and row 4. And hence what we can do next as our row operation is just appropriately scale and subtract row 2 from row 3 and row 1, row 3 and row 4, so that we can reduce these third and fourth rows to zeros. Because in your mind, you should visualize this entire thing as a structure of ones that are multiplied with A2 minus A1, then A3 minus A1, and A4 minus A1. And once you have this, that's it. Because you can then scale this row by A2 minus A1 to have it as all ones. And all of these operations involving this scalar division are possible because we have 4 distinct numbers. And what it means is that A2 minus A1 cannot be 0. Hence, this is justified. And once we have these 2 rows, we see that they are linearly independent, as in they are not scalar multiples of each other. Hence, the rank of this matrix is 2. And that's it. Interesting thing, even if we did not have this positive in the question, just this distinct would have sufficed. Think about it. Maybe comment out that I was wrong with this and this positive was required. And some base to build your base is, now, when you have this world of complicated things, in this case, our world is this vector space coming from the matrix, and the things are the vectors, then those complicated things can be broken down into stuff that really matters. In this case, we broke down this matrix essentially into this. So whatever is the row space of this matrix, the same thing can be generated by this. That's a good way to look at that. And if you like this, then the request is to break down the space of the problems that you face in life into what are actually the real important problems. Try doing that. It may have a simplistic view of how things really are. Take care. Hare Krishna.